And welcome back. We're going to continue looking at file I/O. Particularly, let's get started by looking at how we can write to a text file. We'll eventually look at how to read from it, and some of this you may already recall. But again, we're going to go ahead and take a deeper, more granular look at things. So let's first start with the PrintWriter class. The class PrintWriter is going to be our preferred stream class for writing to a text file. Now, an object of the class PrintWriter has the methods print and println, which are very much like the methods system.out.print and system.out.println that we use for screen output. However, with an object of the class PrintWriter, that output is instead going to a text file. Now, one thing you'll note about PrintWriter is that it's part of the java.io libraries. In fact, all the files of our IO related classes that we introduce are going to be in that package. So we should expect all our program files to begin with the import statements. For example, we'll have file.outputStream, file.notFound exception, and of course PrintWriter. And you'll notice they're all following this import java.io standard that is, of course, what we need to have. Now, if we want to create an object of that class, PrintWriter, we say PrintWriter outputStream equals null. And then, of course, we're actually going to create that object and define it. So we have outputStream equals new PrintWriter, and this is going to, of course, have in parentheses new file outputStream stuff.txt being replaced by whatever file name that we want to actually write to. And you notice I have a little comment here that says place inside of a try catch. So this piece right here is going to need to be in a try catch, and we'll talk about why that is here in a second. The thing that we need to know to start off, though, is that our program is, of course, creating that file, and that file, stuff.txt in this case, can be read using an editor, or it could also be read using another Java program. So we'll actually look at, let's call opening that file, because we want to be able to edit. We want to be able to write things into that file. Well, the variable outputStream is of type PrintWriter and is declared outside of the try block. We connect to that stream using the outputStream to the file named stuff.txt, and when we connect to it, we are what's doing called opening the file. All right, it's maybe not what we traditionally think of opening, but in terms of a programming sense, this is what we're referring to. We're being able to access the contents that are inside that file. When you connect a file to a stream in this way, our program's always going to start off with an empty file. It doesn't matter if there was something in it or it's empty, because for example, if stuff.txt was already in our place, that's okay. Java says throw everything out. And if it does not exist, Java says, hey, we need this file, let's go ahead and create it. So let's go ahead and see, what is this file output stream actually doing? Well, if we want to think about this, we want to associate file output stream, or our output stream really, with that file named stuff.txt. We want these two things to work together to actually put data there. However, the class PrintWriter, when we actually look at it, has no constructor that will pass in a file name as its argument. Instead, we have to use the class file output stream to create that stream that can then be used as an argument to the PrintWriter constructor. So that's why if you look at it, it's a PrintWriter, and then inside we have parentheses, new file output stream. So that expression, new file output stream stuff.txt, takes a file name in as an argument and creates what's known as an anonymous object of that class file output stream, which then uses an argument to a constructor for the class PrintWriter as follows: new PrintWriter, parentheses, new file output stream, parentheses, stuff.txt. Again, if some of these terminologies might seem a little overwhelming, but just know that you have to do it here in this format. So if you're always going to have a new PrintWriter, just like we'd have a new scanner object, like when we did on our keyboard and stuff like that. We're just doing a new PrintWriter, but instead of putting in just a like system.in or empty parentheses, we have to put inside here this new file output stream stuff.txt. And that's, again, the biggest thing we have to kind of get used to doing is we have a new invocation inside of this one. Now, we need to know about reading that file name, because when we look at that statement, we have stuff.txt, right? And this is produced by an object of that class PrintWriter. And if you look at the name of the file, it's stuff.txt, we'll see that it is a string value because it's given in quotes. If we want to read the name of the file from the keyboard, for example, let's just say I want the user to be able to choose let's say they have a list of files, and I want you to choose which file do you want to read from. Well, you could assign that name to a variable of type string, and then use the string variable as the argument to a file output stream constructor. So for example, maybe you have a string variable that says file name, and it's like they go and they do a keyboard input and file name equals whatever they type in, and then it takes file in as a constructor and tries to read it in. Now, there is something we have to keep in mind here, which is the file not found exception. Because, of course, what happens if it goes right to that file, but that file's not there? Well, whenever we open a text file, and remember this is the definition of opening a text file, not again what we might think of opening a text file, but whenever we open a text file, whether it exists or does not exist, a file not found exception can be thrown. And any possible exception, of course, as we know from our previous lessons, should be caught in a catch block. Now note that is the file output stream constructor that is actually what's going to throw, not a file not found exception. All right, so it's not necessarily the PrintWriter class that's doing this, it's the file output stream. Very important distinction here because the PrintWriter is not actually what's opening the file. It's the file output stream that opens that file. Now our try block only encloses the opening of the file. So just that one line of code, that output stream that we're trying to write to, is what's actually in there. That's the only place that an exception can be thrown when we're opening this file. You'll also note that the variable output stream is declared outside of the try block. So when we do PrintWriter output stream equals null, that is outside of that try block. And the reason for that is we want to be able to use that stream probably elsewhere in a program. We want to be able to have those values available to us. So remember that just like with when we deal with like loops and conditionals, anything declared inside a block of code, even a try block, is local to the block. So it's very important for us to say PrintWriter output stream equals null, because again we don't want to initialize it yet till we go into that try block. But once we're in that try block, of course, then we can create where we want to point it to. So let's open a text file for writing output. So we create a stream of the class PrintWriter and we connect it to a text file as follows. So we have a PrintWriter output stream name, so it could be, for example, output stream. Then we say the output stream name is then equal to a new PrintWriter instance, which has as an argument a new file output stream, which then has as its argument some file name. We can use, of course, the methods printLine and print to write the file. Biggest difference, just as we expect, print is going to do on the same line. PrintLine will put each output on its own line. When used in this way, the file output stream constructor, and thus the PrintWriter constructor invocation, can throw that file not found exception because, of course, they're looking for that file to exist. And if it doesn't exist, we're going to have an error. This, of course, isn't what's known as an I/O exception. File not found exception is just, you can think of as a derived version of that I/O exception. Now, again, looking at those individual argument pieces, remember we looked at stuff.txt. Well, that's a file name that exists. And the rules for how we spell our file names are going to be very dependent upon what operating system we're using, not on Java. Java actually doesn't have much to say about what types of files we're going to use. Now, when you give a file name to a Java constructor for a stream, you're not giving the constructor a Java identifier. Instead, you're giving the constructor a string that's corresponding to that file name. A suffix such as .txt in stuff.txt has no special meaning to the Java program. In fact, Java could care less what that file extension is. Instead, we're using that suffix txt to just indicate a text file, but txt is just a very common convention that is used for text files. And one thing to keep in mind is no matter what kind of file we're feeding into this file input, we can only use file names that are allowed by our operating system. And we're going to continue to use text files in our upcoming demonstrations because, again, those are very easy for us to learn and to use. But technically, if we wanted to use a specific file type, we could do that here as well. Now, a file has technically two names, and this is important to note that every input and every output file used by our program has two names. We have the real file name that's used by the operating system, and then the name of the stream that's connected to the file, for example, output stream. The stream name is just simply a temporary name for that file. It's a name that is used within your program. We're not going to go and call stuff.txt elsewhere in a program. Instead, we'll call output stream. So just important to keep that in mind. After you connect that file to the stream, your program's always going to refer to that file by the stream name. Now, we already mentioned this, but file not found exception is very important and very needed to be handled, because we said when we open a text file for writing an output to that file, the constructor might throw a file not found exception. However, in this situation, you might say, well, we want to create a new file for output. So why do we care if this file is not found? Because, of course, it's not there. Well, the answer is simply that execution is just poorly named. That exception, it doesn't necessarily mean that, when we say it's like, well, it's not that the file is not found. In this case, it means, well, the file could not be created. So Java says, hey, there's no file here. Let me go ahead and attempt to create this file. And it fails. Well, in this case, the file not found exception is thrown because it's impossible to create the file. For example, the file names are already used for a directory, such as a folder. Or maybe it's lacking certain permissions that it can't actually write that certain file there. Now, we had already mentioned that file not found is part of course, the I/O exceptions. And when we look at I/O exceptions, these are going to happen anytime we start dealing with file I/O. And there are many situations in which our code might throw in an exception of some class, such as the file not found exception, which we just looked at. Many of these various exception classes are descended of course, the I/O exception, as we kind of have already mentioned. The class I/O exception is the root class. So you can think of it as the big parent class that's going to deal with any of the various exception classes having to do either with input or with output. And we'll see that as we branch further into output and, of course, even stuff with binary files. Now, we already, of course, mentioned a couple of these, but there's print, printline, and printf that are going to be handled with our output streams. A file not found exception, as we said, is a kind of I/O exception. So a catch block for an I/O exception technically is also going to work. So if you said doing a file not found exception, you said, I'm just going to do an I/O exception, it would work. However, whenever we are writing exceptions, and we talked about this previously, it's always best to have a most specific exception as possible because it's going to give us much more information to work with. So if I just did a I/O exception, it will handle it. But if I say it's a file not found exception, then if I have that exception triggered, I know exactly what I need to look for to go ahead and be able to address that potentially with some kind of software fix. Now, the method printline of the class PrintWriter works the same as writing to a text file as the method system.out.println works for writing to the screen. The class PrintWriter, for example, also has the methods print and printf, which behave just like system.out.print and system.out.printf, except that the output is going to a text file. Now, one of the last things we need to talk about is closing our file, and then we can actually look at our code here. So when we talk about closing a file, let's say our program's done writing to the file, we need to close that stream. And you say, well, what does this mean? Well, the stream, which we have output stream that's connected to stuff.txt, we want to close that with output stream.close. The class PrintWriter and every other class for file output or file input has a method named close. When you invoke the method close, it's going to release any resources used to connect to that stream and does any other background housekeeping that is needed. If your program does not close the file before the program ends, fortunately, don't worry, Java will close that for you, but it's safe to close the file with an explicit call to close. And why do we want to do this? Well, before I talk about why we want to close, let's first discuss this thing known as a buffer. Output streams are connected, of course, to files, and these often are buffered, which means rather than physically writing every instance of output data as soon as possible, the data is saved in a temporary location, typically in memory, known as a buffer. When enough data has then been accumulated within this temporary location, it is then physically written to a file. This, of course, can add to our efficiency, potentially slowing things down or speeding things up, because physical writes, when we have to write every time to a file, it can be a lot slower. Now, the method flush causes a physical write to the file of any buffer data. So if we want to say, hey, we want to do this sooner, let's flush that data. It's going to clear it out of memory, and we're going to be good to go. The method close, when we do that, when we call it, it's doing the same thing and say, hey, if it's got any of that buffer data, let's go ahead and flush that out and put it into the file. Now let's go ahead and look at how to actually close the file and why we want to do this. Well, when our program is finished writing to a file or reading from a file, it should close the stream that's connected to the file by invoking the method close. It may seem like there's no reason to use the method close to close the file because after all, if our program ends normally and we don't close the file, the system's going to do that for us. So why should we bother to include this close invocation with an explicit call? Well, there's two reasons. First, if your program ends abnormally, then Java may not be able to close the file for you and can actually damage your file. In particular, if it's, for example, an output file, anything that's buffered may not have been actually written to your file, and so our file is going to be incomplete. And so basically, the sooner that we close the file, the less likely that this is to happen. The second reason is that if our program writes to a file and later reads from that same file, it has to first close the file after it's written. So in that same program, for example, let's say we're going to close the stream and then later we want to read input from it. If we don't close that stream, it's not going to be able to have that proper file read. So we always have to make sure whenever we're closing it, even if we're going to say, hey, no, we're going to do this, we're going to write to this file, and then I'm going to the same program, I'm going to open it back up so I can read what's actually written in that file. I need to make sure that those files get closed. And so here we are with our text file output demo, and you can see in here I'm going to go ahead and create my stuff.txt. You'll see here we have all our different import statements that we are going to need. We have our PrintWriter output stream. We set to null, and the reason why we want to set to null is because it is a class type. I could just say file output stream, and I could just have it there, but setting it to null allows it to exist as an object without retaining any values. In here we have our try statement. You notice it only encapsulates a single line of code, which of course is going to grab our new PrintWriter, which is going to invoke a new file output stream of stuff.txt. We of course have to catch them. We're going to be specific and use file not found. We could of course use the IO exception, but this is much more specific, and we're just going to say, hey, we have an error opening the file. And of course, if we do, we just terminate the program. Otherwise, we're just going to write out some code to there. And of course, I'm also going to give an example here. I didn't quite finish this one because I wanted to show you real quick how we can do this. Now, this, you notice, is just using output stream.println. But what if I wanted to get some keyboard input and put this in here? Well, here I'm going to enter a line of text. I have a string input equals kb to next line. And all I have to do to enter this in here, I'm just going to say output stream dot, and of course we did print line before, so we do the exact same thing. So we're going to do a print line, and we're just going to do the variable input, which of course is going to allow us to take whatever they typed here and put that into our program. So let's go ahead and give that a quick run. It's just going to say writing to file, so there's that right there. And then it says enter a line of text, so let's just say this text was entered from the keyboard. Hit enter, we get end of program. And of course, what we want to see, where's that file? So if we come back here to my 4.2, I'm just going to go ahead and tell this to refresh here. And I want to see that file. And of course, sometimes it will show up in here, and there it is. And there's my stuff.txt, so let's go ahead and double click that. And you can see we have the quick brown fox jumps over the lazy dog, and there's that line of text that entered there. It says this text was entered from the keyboard. So that is a quick view of how we're going to handle file, and we're going to, again, keep using this to dive deeper and deeper.